Hey everybody, let me hope you are doing fine. I'm once again back to teach you something about integral calculus. Today we are going to talk about integration of trigonometric functions. So how do we integrate trigonometric functions? Let's begin from what we know, from what we have discussed in the previous lessons. Okay, we know that when you integrate sine x by dx, you end up with a minus cosine of x plus sc. And when you integrate cosine of x by dx, you end up with a sine of x plus sc. Okay. Now, what about the integral of sine nx, by dx, where n is a positive integer? Okay, z means integers in mathematics, so n is a positive integer. What about that? How do we go about it? We'll discuss this in change of variables, but I can quickly remind you what you do. You let p, let's use u, equals to nx. So differentiate du by dx is equal to n, and make dx the subject. So dx is du over n. Now we just go ahead and substitute. We see that the integral of sine nx by dx will be the same thing as integral of sine u, and then dx changes to du over n. So this becomes 1 over n, integral of sine u, So integrate sine u. What do you end up? We say that the integral of a sine gives us negative cosine. So we end up with a minus 1 over n cosine of u plus a constant of integration. So let's go to the next page, and I give you, a very quick hint that you can always use and come up with these results so fast. So the integral of sine nx by dx, we are discovering it is now negative 1 over n cosine of u, but u is nx, plus sc. So now what's the shortcut? The shortcut is always differentiate this angle. The angle is nx. It is a multiple of x, because n is a positive integer. It is a whole number, but a positive number. So differentiate, then divide the integral of sine by the derivative. That means that if I have integral of sine 4x by dx, quickly I can differentiate 4x and I end up with 1 over 4. Then I know the derivative, the integral of a sine is a negative cosine of 4x plus sc. And very fast I have the answer. What about the integral? The integral of sine 3x is still same story. This is going to be, you may first write, if you want, you can write what is the integral of a sine is negative cosine of 3x. Then let me go ahead and differentiate the angle here. If I differentiate 3x, I get 3. So I divide by that derivative, then plus sc. So you can always, write these answers very fast. But if you don't want to write very fast, you can always, make use of a substitution like a u to stand for 3x, and then go ahead and change variables, and you'll have the answer so fast. So let's talk about now cosine. So what is the integral of cosine nx by dx, where n is a member of positive integers. You can even call them natural numbers if you want. Okay. So what do we do in that case? Still use the change of variables as a method, differential the method. So we let P equals to that angle nx, then dp by dx is equal to n. So dx is dp divided by n. If you go ahead, cross multiply and make a dx the subject, not an issue to somebody in A level. Okay, so the integral of cosine nx by dx will now be equal to the integral of cosine of p, then this is dp out of n. But since n is a constant, you can pull it outside and it becomes 1 over n. And what is the integral of a cosine? Okay, what do you get if you integrate a cosine? When we integrate a cosine, we shall end up with a sine, okay, of p plus a constant of integration. We can say that therefore, when I integrate cosine of nx by dx, I end up with the, okay, sine of nx over n plus c. So the same hint works. Just differentiate the angle, then get the integral of cosine and divide by that derivative. So as simple as that, you have the answers. Okay, why are we bringing in this? Let's see how it is used in integrating powers of sine x and cosine x. Try to be careful as we integrate powers of sine x and cosine x. So we shall begin by looking at even powers of sine x and cosine x. So let's write down something to integrate. So to integrate sine squared and cos squared of x, we express the function in terms of the cosine of the double angle. So let's get ourselves reminded of the double angle formula. You remember your trigonometry? We said that cosine of 2x is the same thing as cos squared x minus sine squared x. That's trigonometry. Is an identity, but also have this Pythagorean identity. Okay, but cos squared x plus sine squared x is equal to 1. That's the Pythagorean identity. Okay, if you make cos squared the subject, okay, we have cos squared of x is equal to 1 minus sine squared x. Or if you want, you can make sine squared x is equal to 1 minus cos squared x. Now, what does that mean? If we go back here and pick the identity, we have cos 2x equals to cos squared x minus sine squared. But now, sine squared is 1 minus cos squared x. That's if I decide to substitute for sine squared x in terms of cosine squared. So this is a 2 cosine squared x minus 1 is equal to cos 2x. Now, if I make a cos squared x the subject, if I decide to make cos squared x the subject, then I can say that cos squared x is 1/2 of 1 plus cos 2x. That is the cos squared x, 1/2 of 1 plus. So when we are integrating cosine squared, okay, we make use of this and then move so fast and find the integral. Or if one decided, okay, at this stage, you decide to substitute for cosine instead of substituting for sine, it will give us the identity which I'm writing on next page. So we can write cos of 2x Okay, this the mother identity is a cos squared of x minus sine squared of x. But now this time, we want to substitute for cosine squared in terms of sine squared. So we know cos squared is 1 minus sine squared of x, then minus this other sine squared x. And if you go ahead and do your math, this is going to be 1 minus 2 sine squared x as equal to cos of 2x. Okay, cos of 2x. Now go ahead and make sine squared the subject. So what does it mean? This means that if you are to make sine squared the subject, that is isolating a sine on one side and then the rest go the other side, this is going to be 1/2 of 1 minus cos 2x. So let me write these results here because we shall make use of these as we move on to integrate trigonometric functions. Okay, so this is important for you as a student to make note of what is important, what you are going to use most. So we can see that as cosine squared of x is 1/2 of 1 plus cos 2x. Okay, then the sine rather, then sine squared of x is also 1/2 of 1 minus, that's the difference, 1 minus cosine of 2x. So cos squared and sine squared has been expressed in terms of the cosine of double angles, and therefore, okay, if we have been asked to integrate, okay, sine squared x by dx, what we do is just substitute for sine in terms of the cosine of double angles. So it is halfway of 1 minus cos 2x by dx. Okay, yeah, pull out a half because that is a constant. Okay, integrate 1 minus cosine of 2x by dx. So what do we get? Very simple. Okay, let's now integrate. When you integrate 1 with respect to x, you get x. Okay, and when you integrate a cosine, you get a sine of 2x. But remember, we have just said that differentiate the angle and divide by the derivative, then plus a constant of integration. Okay, so let's move on. We can write this as x over 2 if you want, minus sine 2x over 4 plus a constant of integration. And we are done. We have integrated the sine squared x by dx. So what trick have we used? It is expressing in terms of the cosine of double angles. That's the trick, which is also important. So this result too, you may not, learn it by heart, but you at least must know what we get at the end of the day. Okay, so let's try cosine. Okay, integrating, change the pen color, integrating cos squared x by dx. We end up with the integral. Cosine is halfway of 1 plus cos 2x by dx. And what will change between this, between cosine and the sine, when you look at these two, they're almost the same, but it is only this part. This is minus and this is a plus. So the answer will be the same. The same method, you end up with the x over 2, but now this time plus, okay, sine 2x over 4 plus a constant of integration. You are done with integrating sine squared x and the cos squared x. Now the question is, if you are integrating sine squared of 2x, okay, by dx, look at this. this is x and this is 2x. It is going to be the same. Just come down, okay? Take it easy. This will be a half. It is still going to be a half times the integral of 1 minus. Remember, this is a half angle, and you want to write this as a double angle. So the double of 2 is 4x. Then you just go ahead and integrate. Okay, go ahead and integrate the function. Life will be very easy for you. Very, very easy for you. Okay, you can tell what we get out of this. So be sensitive. The angle they write here, okay, the angle you are given here will be a half angle if you write in terms of double angle. So it in terms of double angle, what you write the other side will always double this. Okay, so let's get used to writing, half angles in terms of double angles. Okay, even powers of different angles of sines and the cosines, and then see what are we saying. Let's put this in words. If I have sine squared of 3x and I want to write this as a double angle in terms of cosine, it will be halfway of, it is always 1 minus cosine. Okay, then this cosine must be twice this angle. So cos of 6x sine of 6x, sine squared of 6x, if you want, in terms of double angle, it is a halfway of 1 minus cosine of 12x. Okay, so what's the point of emphasis? The angle here must double this. Okay, so if I have cos squared a half of x, it is going to be halfway of 1 minus 1 plus, for cosine is 1 plus cosine of x, because when I double a half, I get x, I get 1. So if I want a cos squared of 8x, it will be a half of 1 plus cosine of 16x. So if I'm given a task of integrating, I'm told to integrate cos squared of 8x by dx, simply write a half times the integral of 1 plus cos of 16x, okay, with respect to x, integrate it. And therefore, what do you get here? Okay, this is going to be a half of x. The integral of a cosine is always a positive sign, sine 16x, but don't forget to differentiate the angle and divide by that derivative. Okay, then plus the constant of integration. We are done. So what is the key point? The key point lies in expressing the powers of sines and cosines, the even powers here, not any power, but these are even powers, okay, of sine and cosine in terms of the double angle. Okay, and the even power we're talking about here is a 2. Other powers, let's see what happens. Now, there are other even powers that are more than 2, and you could be told to integrate sine to the 4 of x by dx. Okay, this can be written as the integral of sine squared x, then squared. Remember, there's something you should not forget here. Okay, if I write sine to power 4 of x, it is a short way of writing sine of x to the power 4. We just want to avoid the brackets, and this can be written as a sine of x squared, then I square this using the rules of indices. Powers will multiply and give me back my 4. Okay, so this is what you are seeing inside here. But what about how do we write sine squared in terms of a double angle? Okay, we know that sine squared in terms of double angle is halfway. of 1 minus cos 2x. Then we are going ahead to square this and integrating with respect to x. So what we get? This is going to be, okay, let me go ahead and write this as a quarter. When I square half, I get a quarter and put outside. Then I have 1 minus 2 cosine of 2x, then plus cos squared of 2x. Now, another even power or a square of cosine 2x appears, and we have to express this in terms of double angles and integrate. So this will be a quarter, okay, integral of 1 minus 2 cos 2x. Then this is plus, no, cos squared is a halfway of 1 plus, now this is going to be cos 4x, okay, then by dx, let me change the brackets here, by dx. Okay, let's integrate. Or before we integrate, we can still factor out, some, or we can correct like terms. This is a quarter integral, okay. I see a 1.5, that is 3 out of 2, okay, minus a 2 cosine of 2x, then plus a half of cosine 4x by dx. And we get a quarter. This is gonna be 3 over 2 of x minus 2 sine 2x over 2 plus sine 4x over 8, okay, then plus a constant of integration. So let me write this so well on the next page. So we end up with the 3 over 8 of x minus sine 2x over 4 plus sine 4x out of 32 plus a constant of integration. That's what we get when we integrate sine to the 4 of x. Now, in the same way, you are going to try the integral of cosine to the power 4 of x by dx, okay? And I'm very sure this will give you 3 over 8 of x plus, the only change is just here, plus a sine 2x over 4, then plus a sine 4x over 32 plus a constant of integration. Okay, what about odd powers? Now, 2, we discuss odd powers of sine x and the cosine of x. Okay, how do we do this? We release one of the factors and make use of Pythagorean, okay, Pythagorean identity, Pythagorean identity. So what are we saying? If you have been told to integrate, okay, sine, let me just write this on next page without wasting time. So if you have been told to integrate sine cubed of x by dx, what we do, we first write this as sine x, then times sine squared x by dx, okay? Then how do we go about this? This is the integral of sine x, but sine squared is 1 minus cosine squared of x. That's the Pythagorean identity we're talking about. Okay, so go ahead and expand this to be the integral of sine x minus sine, okay, x, then cos squared x by dx. So we can write this integral. When you integrate a sine, you get negative cosine of x minus the integral of sine x cos squared x by dx. So here we use what we call a function and its derivative that we discussed. Okay, you let, just to give you a simple, let u equal to cosine of x, such that du by dx is negative sine of x. So dx is du over negative sine of x. So the integral of sine, okay, the integral of sine cubed x by dx will be negative cos of x minus the integral of sine x, then this is u squared d, and dx is du over minus sine of x. So this cancels out, and then you end up with the minus cosine of x minus the integral of u squared d by du. So you go ahead and integrate u squared, you get u cubed over 3, then plus a constant of integration. So let's do that. So that is it. That's what we get when we integrate sine cubed of x. So what are we saying about all the powers of sine and cosine? Okay, be careful. Don't mix this up with the even powers that we have so far discussed. We are still discussing these powers, and the idea is simple. If you are given sine, no, let me check. Let me change this time and use the cosine. Okay, what if you have been given cosine cubed of x by dx? Okay, release one of the factors. You know, cos cubed is cos times cos times cos. So this is the same thing as the cosine of x times cos squared of x by dx. Now we make use of the Pythagorean identity. Cos x, this is 1 minus sine squared x by dx. So next, what do? We integrate, okay, a cos of x, okay, minus, or if you don't want to expand, let me teach you another way of going about this. If you don't want to expand, this is how you go about it. You maintain, you maintain the cosine, and what you do, you let maybe u equals to just sine, not sine squared, sine of x by, okay, so it means that du by dx will be cosine of x, and therefore if you make dx the subject, dx is du over cosine of x. So the integral of cosine cubed x by dx, okay, will now be the integral of cos x into 1 minus u squared d, then du over cosine x, and this will cancel out. So you are only integrating 1 minus u squared with respect to u. It is going to be u minus, this is u cubed over 3, then plus a constant. The last step is putting back u in terms of, u is standing for a sine. So this is going to be sine x minus sine cubed x out of 3 plus a constant of integration, and you are done. So it's not a big deal. So what about other odd powers more than 3? Still, this is simple, okay? It is really very simple. If you are told to integrate sine power 5 of x by dx, okay, look at this as the integral of sine x, then sine to the power 4 of x by dx, okay? But we know that this can be written as integral of sine x times sine squared x, then squared by dx. Okay, this is the integral of sine x, okay, into 1 minus cos squared x by dx. Okay, so what do? We go ahead and look at this as the integral of sine x. So there is a square here. Sine x into 1 minus 2, okay, cos to the power, so cos squared x, then plus a cos power 4 x by dx. Now at this stage, just let u equal to cos of x. So it will mean that du by dx is negative sine of x. And if you make dx the subject, it will give you du over a negative sine of x. So the integral becomes sine to the power 5 of x by dx will be the integral of sine x, then 1 minus 2 u squared plus u to the power 4 times du over minus sine x. So this cancels out and it leaves you with a negative outside. Integrating 1 with respect to u, you get u minus, okay, 2 over 3 of u cubed plus u to the power 5 over 5 plus sc. So next what you do, you substitute u. Remember, u in this case is standing for cosine, so it is as simple as that. So go ahead and try to integrate cos to power 5. Let me just give it to you as an exercise on the next page. This lesson ends here today. We don't want to go beyond the 30 minutes. Online, that's too much for an online student. So let's integrate the products of sines and cosines next time. Remember, this is lesson 9. Thank you so much for listening, ladies and gentlemen. Don't forget to subscribe and to hit the notification bell.